let's consider a couple of matrices here, A and B. And let's see what happens when we multiply A times B. Well, if we go through the process of multiplying these matrices out, we would find that A times B is equal to 1, 0, 0, 1, this. Now, let's try this. Let's multiply B times A. Now, usually, when we multiply A times B, we're not going to get the same thing as when we multiply B times A. But in this case, we do. A times B and B times A both give us this matrix here. This matrix is called the identity matrix. Now, this is a 2 by 2 identity, and we can recognize the identity matrix because there are ones on the main diagonal and zeros every place else. Now, there's the 3 by 3 identity matrix, the 4 by 4, the 100 by 100 identity matrix, and all of these are just ones on the main diagonal and zeros every place else. So when we multiply A times B and B times A and we get this, then that means that these two matrices are inverses of each other. It's sort of like you can think of multiplying 2 times 1/2, you get 1. Well, 1 is kind of corresponding in real numbers to the identity matrix with matrices. See, if you multiply 2 times 1/2, you get 1. Well, if you multiply A times B, you get the matrix 1 there. You can kind of think of it that way. Now, also, if you multiply 2 times 1, you get 2. Well, that's the same way it is with matrices. If you multiply matrix A times the identity matrix, you just get matrix A back. If you multiply matrix B times the identity matrix, you get matrix B back. So this identity matrix kind of plays the role of 1, okay, like with real numbers. Now, there are different ways to compute and find the identity matrix, or to find an inverse matrix. We're not going to focus on that right now. What I want you to realize is, yeah, there is this identity matrix, and there are inverse matrices. There are matrices that we can multiply together and we get this identity matrix. Okay? In other words, we're going to use this identity matrix to solve some problems. And in particular, the first problem that we want to solve is we want to be able to solve a system of equations with that identity matrix. Now, here's the way we proceed with that. I first of all need to rewrite this system of equations in matrix form. Okay? And this is the matrix form here. We've got 1x plus 2y equals 8. See, if we multiply this out, you can see it's the same information as the system of equations over here. Now, you could look upon this as the matrix A right here. This is the matrix capital X, and this over here is the matrix B. So this is one way we could look upon this as AX equals B. So we could write it that way, where A and B are matrices, X is a matrix. And notice X is capital X. Now, think about this. If A has an inverse, we could do this. We could multiply this side by its inverse and this side by its inverse. In other words, I could multiply both sides by A inverse. It's sort of like if we have 2x equals 6, well, multiply both sides by 1/2. And you get on the left side x, and on the right side you get 1/2 of 6, which is 3. So you get x equals 3. Well, we're doing the same thing here. Notice I'm multiplying the left and the right by A inverse. See? The left side, A inverse. Over here, A inverse. And notice what happens. If I do that, this A inverse times A, well, when you multiply an inverse by the original matrix, so if you multiply A inverse by A, you get the identity matrix. It's like you get 1. It's like when you multiply 2 by 1/2. You get 1. Well, so we get IX equals A inverse B. So look at this. Now let me just write this as just X equals A inverse B. This is like saying, up here, this is like saying 1x equals A inverse B. Well, let's just write x equals A inverse B. Well, it looks like then we have a method for solving this system of equations. We just have x equals A inverse B. So let's see how we would apply that. We've got this system. If we multiply by A inverse over here and A inverse over here, what we're going to have is this. This is like the capital X equals A inverse. This is the inverse of A. So if you take this matrix right here, multiply it by this one, you get I. This is A inverse. So this is A inverse, and of course this is B. And when we multiply this out, we get this matrix, 2, 3. And that is the solution to that system of equations. X equals 2 and Y equals 3. That's our solution. Okay, so let's see how we could use this idea. Here we have a system of equations, and I'm going to put this in my calculator. So I'm going to do second matrix, and I'm come over here to edit. And what I'm going to do is I'm going to enter the A matrix right here, the 1, 1, 1. So this is another method that we can use to solve a system of equations. This is a 3 by 3. And I've got the 1, 1, 1. There we go. And then down the second row is 2, 1, negative 2. And then the third row, negative 3, 2, 1. Okay, now all I'm doing is putting in matrix A there. And notice I've got it 1, 1, 1, 2, 1, negative 2, and negative 3, 2, 1. Good. Now let me put in the B matrix. So I'm going to come down, I'm going to come over here to edit, come down to B. And this one is going to be a 3 by 1. So I'll put in those values. See? So here we go. I got a 9, negative 1, and 4. There it is. So there's my B matrix, 9, negative 1, 4. So I'm going to quit now. Now I want to enter A inverse B, and that's going to be my solution. That's going to give me X, Y, and Z. So here we go. Second matrix A. Now, how I indicate that I want the inverse is right here. This little x to the negative 1, A inverse, and then I do second matrix B. There we go, and then enter. Now look, so here's what you've got. You've got x equals 2, y equals 3, and z equals 4. So that's another way that you can solve a system of equations using matrices, and in particular, using inverse matrices.